think I'm live? Okay, I am. Sweet. I think I'm live? Okay, I am. Sweet. I'm gonna test the delay. I think I'm live? Okay, I am. Sweet. Why is it repeating? What the fuck? I'm gonna test the delay. I think I'm live? Okay, I am. Sweet. Why is it repeating? What the fuck? I'm gonna test the delay. I'm gonna test the delay. I'm live? Okay, I am. Sweet. Why is it repeating? Delay. I'm gonna test the delay. I'm gonna test the delay. I'm live? Okay, I am. Delay. Okay, this is about a 20-second delay. That's good to know. Hello, Ron, whoever that is. Don't. This is already a mistake. There's only one person here. This is already a mistake. Alright. I'm still a little early. I'll wait for people to join. How can I see who's watching? One watching now. Ron. I don't even have a Ron. It doesn't help that you said it's me. You're the only one here. Should I start? You tell me. Oh, snap. It's Cameron. What's up? Oh, dude. That makes sense. I get it now. All right. That makes total sense. All right. I only got like 3 people in here. I'm dying of my allergy still. So it's going to go as long as it goes. All right. Let me... Alright, I guess I will just go ahead and go over trig for geometry. For those watching, I will just be doing a few things. I will be doing the basic trig functions, sine, cosine, tangent, the inverses, and law of sines, law of cosines. That's all we're going to do today. We're going to go as long as it takes for me to suddenly stop and start sneezing. I'll start from the beginning, just the general idea and basics, and we'll just go from there. I'm kind of winging it. I'm using Khan Academy as like a resource because I don't want to use the school's my school's curriculum in case there's some legal issue that I didn't find out about. So I'm using Khan Academy, which is public, and I will be going off of that. All right. So in geometry, there is a use for what is called trigonometry. Trigonometry is, the way I would describe it is, we're using right triangles. That's awful. We're using right triangles to basically see how a lot of things work. Right triangles are in everything. Everything can be parsed down to a bunch of right triangles. And a right triangle is something that has a 90-degree angle, usually denoted by that little red box. It's usually red. It could be whatever. It could just be black, white, whatever. But that box tells you that that angle is 90 degrees. That makes this triangle special. It has a lot of different properties. Something that we have gone over and done before, something you may have heard, is Pythagorean theorem. If my handwriting sucks, it's because I'm not used to this. Oh, God. I'm not used to this drawing tablet thing, so it might just be bad. But anyway, if I was to label these sides, A, B, and C, Pythagorean theorem states that if you square two of the sides and add them together, it'll equal one of the other sides squared. Now, I didn't say what those sides were called on purpose. A right triangle has two aspects to it. A right triangle has what are called legs and the hypotenuse. So the legs of the triangle are essentially the two sides that create the 90 degrees. What that means is, if I looked at all three sides of this triangle, the two sides that... The stream is off. What do you mean the stream is off? Did it stop streaming? Cameron, you're my eyes and ears. What do you mean the stream is off? Stream is on for you, so there's no issues. I guess just refresh, Ron. It should be fine. Everything on my side is showing fine. I haven't got any notifications, but that doesn't mean anything. Anyway, hopefully it's still going. Let me go ahead and just unhighlight that. So, back to what I was saying about the sides of the triangle. The legs are the two sides that create the 90 degrees. In other words, look at the two sides that connect, and where they connect is the 90 degrees. A and C here connect and don't make a 90 degree. But what a bad highlight. A and B connect together at this point and create 90 degrees. So those are the legs. I'll go ahead and write that here. Two sides. Oh my God. Sides of the right, triangle that make the 90 degree angle. My handwriting is garbage. I am so sorry. Anyway, that's the legs. I'll highlight it in yellow, I guess. Legs of the triangle. Legs of the triangle are there. Oh, God. Okay. So that leaves one more type of side, which is the hypotenuse. I will highlight it in a different color. The hypotenuse is what's left over here. It is C. So what makes a hypotenuse a hypotenuse? Where the word comes from, couldn't tell you. I'm not that smart. But the hypotenuse is the longest side of your right triangle. I am so sorry about my handwriting. This is awful. Anyway, it's the longest side of the right triangle, and it's also opposite the 90 degree angle. What that means by opposite. It's important you understand what I mean by opposite. If I was to look position-wise at this right triangle, right here in red is my 90 degree. By opposite, I mean if I was standing on this right triangle, if I was in this triangular room and I'm standing here in the corner and my back is facing away from the corner, if I was to walk to the opposite wall, the other side, right there, that is the opposite side of the right triangle, and the opposite side of the hypotenuse. So, should I do a different highlight color? I feel like they're too similar. Maybe a darker green. It's a little bit better. So that's what I mean. Opposite side of the right triangle is the hypotenuse. It has a specific name. It will never, ever be considered anything else. It is always the hypotenuse. Color that all in. Great. So that's a quick intro to a right triangle. I haven't even touched trig yet. I'll just go right triangle info, I guess. So, easy as that. Right triangles are these specific types. They have two aspects, legs and hypotenuse. And the Pythagorean theorem is only used for right triangles. So it's only used for our two legs. So this leg squared, a squared plus b squared, will equal this leg, or this hypotenuse squared. So no matter what these numbers are, when you square them, which is multiply them by themselves, and you add them together, you will get your hypotenuse. Let me go ahead and move over. Oh, I am so bad at this. Why do you guys like me? I'm going to move down. I'm going to try to draw a new right triangle poorly. Ready? Bad. Bad. You get the idea. It's fine. We're fine. This is very professional. A, B, and C. So when you're looking at a right triangle or any type of 3D shape or 2D shape, the angles are going to be labeled in capital letters, and the sides are going to be labeled in lowercase. Usually, when math textbooks and math problems are nice to you, the opposite angles in their sides are going to be the same letter, just uppercase and lowercase. That can change. They do this specifically for positioning sake, so you understand what side I'm talking about when I say capital A, lowercase a. They're always the opposites of one another. So, trigonometry. So, the idea behind trig is that there are three major functions. And what the functions do is they take in trig functions, take in an angle measurement, and spit out a ratio between side lengths. I know that sounds weird, but that's all these things do. Basically, you plug in a degree value. The trig function recognizes it as an angle. It assumes it is a part of a right triangle, and it will spit out a ratio between some of the sides. Each trig function has its own set of sides that it focuses on. And let me go ahead and write them out. So we got sine. We got, I'll do cosine in red, cosine, and tangent. I will try to be consistent with the coloring as we go, so you know which ones I'm working with. Let me move up a little bit. Can I zoom out? Am I bad at this? Zoom out. Zoom out. Hey, okay. Zoom out more. I could just write smaller, but no. Anyway, so sine, cosine, and tangent have different ways of writing it. I'll go ahead and write it. So sine, I'm bad at this. Sine, we never write all of the names. We always write the first three letters. So sine is like this. Sine of an angle. I'm going to put x degrees. Usually it's just x, or in later math you'll see theta. This is just a Greek letter that they use to signify angles. It lets all people working on it know that you're working with an angle. Yeah, let me go ahead and erase this. I need more space, I'm realizing. I'm just going to do the sign for now. So sine of an angle. What does that mean? Well, basically, the sine of an angle is saying, hey, let's get the angle, whatever it is, and let's see what ratio, what sides of a triangle created that angle. Just like how these two sides here, A and B, created 90, the sine function is trying to figure out what sides created this angle. Now, let's say sine of x is the value we don't know. We need to figure out what that is. Or maybe we don't. We just have x signified there. And it just says, what's the sign? Well, each one of these, sine in particular, has a rule. There's always a fraction. And on top is the opposite side length. And below is the hypotenuse. So in our little example up here, if I said the sine of the letter capital A is my angle, that is what I'm focusing on. So now, essentially, picture yourself in a triangular room. You're standing in the corner. What the sine of A needs is the opposite side divided by the hypotenuse. So let's start with the opposite side. Here's A. I'm going to follow along as if I'm standing in the corner, and I'm going to walk to the furthest possible wall I could hit, and that's this opposite side. So capital A is opposite lowercase a, so that length will go on top. And the hypotenuse. So the hypotenuse on the bottom. Hypotenuse is always the same side on a right triangle. I'll go back up to what it means. Hypotenuse is the longest side of the right triangle, and it is opposite the 90. Sometimes, like my example down here, we don't have any lengths. We don't have any idea of what side is which, and it may not be drawn to scale, which means it may not be accurate drawing. So we don't really know which side is the longest. If you had numbers there, obviously you can tell which one's the longest. If this said 15, it'd be the longest. If this is like 12 and 9. But right now we just have letters that are representing those spots. So, what the hell is that? No. Looking down here, the thing you really want to focus on when it comes to the hypotenuse is that it's opposite the 90 degrees. It is the opposite side of the 90. So if we go back to our triangle, what side is opposite our 90? Well, focus in on the 90. Pretend your back's in this corner and go to its opposite. This opposite is C. That's bad. C. So the sine of A would be lowercase a over C. We are going to do cosine next with the same triangle. Cosine does something very similar. Cosine, nope, I literally said it out loud and I wrote the wrong thing. Cosine of the angle, I'll put a little degree so you know it's an angle, equals the, oh my God, don't have allergies, adjacent side divided by the hypotenuse. Now, adjacent is not really a word that is used much in like normal speaking. What is happening? I'm just trying to erase. Thank you. So it's might not be something you know off the top of your head, but all it means is next to. So adjacent means next to. So just like how A is opposite, this time we're going to look at adjacent. Hang on. Don't call it an allergy club. You spelled allergy wrong. That's allergic club. That's better. Okay. Anyway, adjacent just means next to. So let's go ahead and focus on an angle. We'll do A again, just like we did sine of A. We'll do cosine. So cosine of capital A is the adjacent side over the hypotenuse. So once again, pretend you're in a triangular room. Your back is in the corner of A, and you need to find which side is next to you. Well, here's the issue. there are two sides that are next to you. You got this is next to you, B, and C is next to you. So what do we do in this case? Well, the thing is, even though C is next to you, it is specifically, we have already established, it is the hypotenuse. Okay. It is specifically the hypotenuse. It is opposite the 90. It can never be anything else. This will never be considered opposite to an angle. It'll never be opposite to or adjacent to an angle. It will always be the hypotenuse. So we can already just get that out of the way. Let's start up our fraction. Hypotenuse goes on the bottom. C. Great. Well, if that's the hypotenuse, what side am I next to? What's the other wall I'm touching? B. I will write out something in a second once we do tangent, but I want to make sure I'm covering my bases here. That's essentially cosine. Now let's go ahead and do the last one, tangent. By the way, there are like 3 other ones that come up later on. Secant, cosecant, and cotangent. Don't worry about them for now unless you're going into like algebra 2 or pre-calc. Tangent. Tangent is the kind of the odd one out because it doesn't have hypotenuse in its rule. So the tangent of an angle is equal to the opposite side divided by the adjacent side. So this doesn't have hypotenuse, so it's all about the positioning of where you're at in your triangular room. So let's go ahead and do it with angle A. Well, angle A, you're backed up into a corner, you're standing here, and you're looking across. You need to find your opposite side first. Well, we already know the opposite side of A. We did it here. But let's do it again. We're standing here, we walk across the room until we hit the wall with our face. The furthest possible wall we hit is A. So that must be our opposite side. Adjacent, again, means next to. Well, once again, we already figured out what is adjacent to A. It's B. But let's figure it out here. We know we don't need the hypotenuse. No hypotenuse comes up at all in tangent. We also know that C is the hypotenuse. So if we're standing next to A and C is the hypotenuse, adjacent must be B. That must be the wall we're next to. This might seem hard to remember. It's handy to have this little key, this little cheat sheet, but there's what's called a mnemonic device that will allow you to remember. A mnemonic device is just like a funny phrase or a set of letters and words that'll help you remember something that is not very intuitive. I know they did mnemonic device. I don't know if they still do them. I'm old. For like the planets of the solar system. Please excuse my dear. Wait, no, that's PEMDAS. Same thing. PEMDAS is please excuse my dear Aunt Sally. But the one for trigonometry, it sounds strange. It's a silly sounding phrase. It says you say it. Don't have allergies. The phrase for trigonometry is so ka toa. Each letter represents the part of the equation. Sine is S, opposite is H, or opposite is O, and H is hypotenuse. S-O-H, so. C is cosine, A is adjacent, H is hypotenuse. C-A-H, ka. Toa, once again, tangent, opposite, adjacent. Tangent, opposite, adjacent. SOHCAHTOA. If you want, you can write it like this too to make it, I don't know, easier for your brain. So ka toa. I don't know. That's how I used to write it. It could be helpful to you. It might be more confusing. Ignore that then. Regardless, that's essentially it for the basics of trig. We'll do a couple examples here in a second. Nope, chat is just doing hashtags, so I got no questions so far. That's nice. I will leave this at the top. I'll just leave that at the top. And we'll go ahead and do an example. Not that. No, whatever. All right, here's one. I'll draw it how they have it. Up. Oh, nope. Stop moving. I'm never doing this again. All right. Perfect triangle. Everything looks exactly how it needs to be. I'm not ashamed of it at all. This side length is 6. This side length is x. And this angle here is 50 degrees. So when you're tackling one of these problems, what you need to do is focus on the thing that you need to solve for. I need to solve for this side, right? So what pieces of information do I have? I have this side length, and I have this angle. All right. I am trying to figure out that side length based solely on my 3 trig functions, sine, cosine, and tangent. Something you need for all of it, you need an angle and you need 2 sides. You need an angle that goes into your trig function, and you need the 2 sides that spit out your answer. So we're going to do that. We're going to figure out what trig function we need. Pretend you are at the 50-degree corner of the room. What 2 sides do you have? You're standing in the corner. The wall next to you, this adjacent side, doesn't have anything on it. It has no indication, no information, and it doesn't have anything to say that I'm solving for it. So I literally don't care about it. It's nothing. This is the adjacent side. So I look at my trig functions and see which ones have adjacent. Letter A. Cosine has adjacent, so I don't need it. And tangent has adjacent, so I don't need it. So the only other one I should use is sine, opposite and hypotenuse. Let me check if I have that. Looking at my 50 degrees in the corner, I see that the opposite side is what I'm looking for. That's the one that has the x on it. And I have my hypotenuse. How did I know this is my hypotenuse? It's opposite the 90 degree. So I'm going to use sine. I'll write it out normally. Sine of x is opposite over hypotenuse. Here, I'll put x degrees so you don't confuse it with that x. Sine of, well, now I'm going to plug in my values. I'm going to plug in what I have. My angle that I'm working with is 50. Sine of 50 is the opposite side divided by the hypotenuse. What's the opposite side? X. It's okay that we don't know what it is. We can solve for it. We don't have adjacent, and we know that opposite the 90 degrees is hypotenuse. 6. So you get to here, and you're like, what do I do? We need to figure out what x is. We need to get x alone. Over here, I'm going to do a side little algebra recap. For those that are not great at algebra, here is 100 equals, what the hell just happened? Oh, we go. Equals x divided by, I don't know, 2. So I need to figure out what that number is. There's some mystery number divided by 2 gets me 100. I'm sure some of you can get that right away. That's fine. But the actual math that goes into it, the actual process, is we need to start canceling things out. We need to get things away. X divided by 2. To get rid of something on the bottom of a fraction, the thing that's being divided, you must do the opposite. So the opposite of dividing is multiplying. And if you multiply both sides of if you multiply one side, you must do it to the other. Now, why am I multiplying by 2? Well, essentially, what I'm multiplying by is 2 over 1. What that does is, when you're multiplying fractions, Please, thank you. The tops multiply together, and the bottoms multiply together. So, on top, x times 2 is 2x. 2 times 1 is 2. Over here, 2 times 100 is 200. I'm not done. X is still not alone. But I have 2 divided by 2 times x. Any number divided by itself, be it 5 over 5, 100 divided by 100, 1 million divided by 1 million. They will always end up being the same thing, and that is 1. So essentially, I don't have 2 divided by 2 times x. I have 1 times x. 1 times x is just x. So I end up being, my missing number was 200. That is a quick recap of just basic algebra. We'll move back over here because we're doing the same thing, except this time we're using trig functions. We have sine of 50 is equal to x over 6. Now, we haven't done anything with sine of 50 yet. Sine of 50 is a number we haven't punched into a calculator. Unfortunately, when it comes to trig, especially at geometry level, there's not a lot of do it by hand kind of thing. You have to plug into a calculator. So let me go ahead and grab the calculator just to have it ready. I'm not going to use it yet. First of all, looking at what we did in the algebra equation over here, we needed to multiply both sides by the denominator to get rid of it. Well, our denominator here is 6. So I'm going to multiply both sides of this equation by 6. X divided by 6 times 6. The 6's cancel out. On this side of the equation, I have 6 sine of 50 equals our missing value. When you have a number touching other things with nothing in between, that just means they're multiplying. So 6 sine of 50 means 6 times the sine of 50. What's nice about a lot of good calculators is that they know that. And so when you type it in, 6 sine 50, close. I'm going to make sure I'm in the right mode. There's 2 types of ways to measure angles, and it's radians and degrees. We are only focusing on degrees today. So I'm in degree mode. So I have 6 sine 50. In other words, 6 times the sine of 50. I hit enter. And I get this decimal, 4.596. I'm going to round up to 4.6. So I get that this missing side here is, I forgot what it was, 4.6. 4.6 is equal to our missing side. What's important here is that we're solving for something like a side out here. Sometimes you'll get a problem where it's it might confuse you the way it's worded. I'll do one right here. Let's see. Actually, I'll just move up. I'll stay on here in case people are following. So right here, let's say I didn't know. I guess I'll just draw another one. I should never draw again. There we go. That's fine. I'm going to say we have this is x, and I'm going to say this is 5. I'm going to say this is 7, and this is, let's see, what is 25 plus 49? That is 56, 76. Whatever the square root of 76 is here. Square root 76. Don't worry about this. I'm just being annoying. 76 equals 8.7. Okay. So this length is 8.7, let's say. I just wanted to be a little accurate. And I said, let's find the cosine of x. Nope. Color code it. Cosine of x. 8.7. Cosine of x. What do I need for cosine? I need my adjacent side divided by the hypotenuse. So I'm at x. That's the corner my back is in. I'm looking in this triangular room. What side am I next to? I'm next to 2 sides, but one of them has to be the hypotenuse. And this time you can use the biggest number, the biggest length as a trick. 5 is smaller than 7, which is smaller than 8.7. 8.7 is the biggest, therefore it must be the hypotenuse. Hypotenuse, according to our mnemonic device here, SOHCAHTOA, hypotenuse goes on the bottom. Our hypotenuse is 8.7. On the top must be the adjacent side. Again, we're in the corner. So I look for what side we're next to, and we're next to 5. Now, what happens here is people get confused. The problem, I didn't write it, but the problem is saying find the cosine of x. It's not asking you to solve for x. It doesn't care about what this is. It wants to know the cosine of x. So it wants to know this ratio. You can technically stop here. This ratio, 5 divided by 8.7, that's totally valid. That's a fraction. It's a weird fraction, but it works. You could plug that in and say the cosine of 8.7 is that, 0.57. Cosine of x, not 8.7. You could do that. It's easier to just leave it as a fraction. So be careful if you run into problems where it's like find the cosine and it has a... If it's like this, find cosine of x. You're not solving for x. It just wants the fraction. We will do one more with tangent. I am going to throw this pen out the window. Okay. I guess I'll just move over here. I'll move down. All right. Is there a tool in here to just make shapes for me? Whatever. Bad. Oh my god. Good enough. All right. Right angle. And I'll say X, Y, bad Y. Oh my god, connect. Y, Z. All right. We got X, Y, Z. Let's just find the sine, cosine, and tangent of each. We'll say this side is, I don't know, 3, 4, and 5. 5. There we go. Sine of, I don't know, Z. Sine of Z. Sine, I guess I'll write my little SOHCAHTOA over here. So, TOA. All right. I'm using just the mnemonic device so we can get used to just being able to say that in your head and remember which is which. SOHCAHTOA. So, it has the letter O and H. That tells me opposite and hypotenuse. So I'm going to look at Z. I'm putting my back in that corner. I walk across the room and I hit my face on the opposite side. That's what goes on top. I'm going to look at this triangle and I'm going to see two ways of solving for the hypotenuse. One, the biggest number. I sincerely hope you're able to figure out which one of these three numbers is the biggest, but if you can't, 3 is smaller than 4, and 4 is smaller than 5. 5 is the biggest, so that must be the hypotenuse. The other way, of course, is just going opposite the 90 degrees and hitting your face on that wall. So, our fraction for sine of Z is 3 over 5. We will do the cosine of Z as well. Cosine of Z. This time, I'm looking at CAH, C-A-H. A is adjacent, H is hypotenuse. Well, I know 3 is my opposite. And I know 5 is the hypotenuse. I'm going to go ahead and write that first. I already know 5 is the hypotenuse. And then I know that 3 is the opposite. So, process of elimination, my adjacent side must be 4. Even if you didn't do process of elimination, you should be able to recognize that this is touching it, and it's not the hypotenuse. Last one is tangent. Tangent of Z. I'm going to show you. I'm going to sneeze all over this thing, and it's going to be awful. Hang on. I'm sorry. Anyway, oh God. Anyway. Tangent is TOA, opposite over adjacent. You can find them by doing the thing where you're standing in the corner and walking across the room, or you can look back at the two things you've already done. Sine requires opposite, and we figured that out already. Sine requires adjacent, and we figured that out already. Done. Thank you, Ron. So there is the very, very basics of how to do trig. It is no more complicated when you're working with a right angle or right triangle and it's just asking for you to solve for sides, or solve for just the fraction. The only other one you'll run into is where x ends up being the hypotenuse, and that just requires a little bit more algebra. We're going to move on to what happens if we have all of our sides and we need to find a missing angle. All right. That's where a new concept comes into play. Inverse trig functions. These are used to solve for missing angles, used to cancel out standard trig functions. We'll see what that means in a second, but I'm just going to write them out. We got sine inverse, denoted by a -1. That's a... There you go. We have cosine inverse and tangent inverse. Now, if you couldn't guess, they coincide with sine, cosine, and tangent. And basically, you use them when you want to get rid of them. You can't divide by sine, cosine, and tangent without a number in them. They're just functions. You can't divide by a function to get rid of it. You can't multiply by a function to get rid of it. You have to, what's called, invert them. So the way it works is essentially, I'll just do a generic example here. Let's say I had the sine of an angle, and I don't know what that angle is, and I want to just get the angle alone. What you would do is sine inverse the whole thing. What that does, essentially, sine is doing something to x. It is getting x, and it's manipulating it. It's creating something else. It's making a fraction. Degrees. The inverse undoes what you're doing. So the sine is doing something. The inverse undoes it. So if I'm undoing it, they cancel out, and I'm just left with the angle. Same thing works with cosine. I'll write it out. Cosine inverse of a cosine function will just give you the angle on the inside. And of course, the same thing works with tangent. So you use these when we have missing angles. And you want to work with that angle or understand what it is. So let me, oh God, I have to draw another one. Let me draw a perfect right triangle. There it is. This time we don't have any of the angles, just like the one above. I'll put C and B. But we do have the sides. I'll say this is 13, this is 14, and this is 15. Okay. Let's say the problem says find the measurement of angle A. So what we're looking for is this angle here, angle A. I'll highlight it, I guess. That's not a highlighter. There. We're looking for angle A. First of all, this problem that I just wrote is being nice. It gives you all three sides. So we actually have full reign to use any of the trig functions. We can use sine, cosine, or tangent because sine, cosine, and tangent... Oh my God, what is wrong with me? Okay. Sine needs opposite hypotenuse, cosine needs adjacent hypotenuse, and tangent uses opposite and adjacent. So all of those sides are available to us, so we just get to choose. A lot of people just assume to go for sine because sine is the first one that you just talked about. It's the first one in the SOHCAHTOA. But we're not going to do that. We're going to use something, we're going to use tangent. Why? Because why not? So first of all, if we're solving for a missing angle, let's set up the equation as if we were using it. So tangent of my angle A is equal to tangent needs opposite and adjacent. It is the TOA part of SOHCAHTOA. SOHCAHTOA. Tangent needs opposite and adjacent. Opposite is the O, A is the adjacent. Opposite of A, walk across the room, slam your face into the wall, is 14. Adjacent is the side that you're touching that isn't the hypotenuse. The hypotenuse is the biggest number, the one opposite the 90 degrees. So it's not 15. It must be 13. Another way of thinking about it, tangent always uses the legs. It never uses the hypotenuse. It always just uses the legs of the triangle. All right. Now we're here, but I can't do anything to get A. I need to find what A equals, but all I have is the tangent of A. The tangent of A is 14 over 13, whatever that is. But I need to find A. A lot of our instincts will be to divide by tangent. You can't do that. You can't divide by a function with no value in it. That is nothing. That's where the inverses comes in. So, just like any other operation, if I was to multiply one side of something, I must do it to the other side to keep it balanced, keep it equal. So if I inverse one side, I must inverse the other. Oh, God. Sorry, I hit the mic. I apologize if that was loud. I don't think it was. Give me 1 second. One second. Sorry. I need to respond to something. All right. So, just like up here, how I have it written, the tangent inverse of a tangent of x just gives you the x. So tangent inverse, tangent of A, just gives you the A. However, this side, something funky is happening. Back at the beginning, I said the trig functions take in an angle and they spit out a ratio. The inverses take in a ratio and spit out an angle. So here's the ratio. Oh my God, stop that. Undo. Nope, that's the wrong button. That one. There we go. The way the tangent inverse, if you want to think about it, it's like thinking about this fraction, is it takes the fraction in and sees, okay, 14 over 13 is the opposite and adjacent sides of some angle. And it's trying to figure out what that angle is that'll give you the exact 14 over 13. We don't need to worry about that crazy math because we have a calculator. And I know what it sounds like. Oh, you're just using a calculator. It's far more complicated to not. And it's like down the road you'll learn about it. For now, it's just important you know how it works. And you know when to use it and when not to. So on your TA84 calculator or any sort of scientific calculator, you have this little second button. It's like a shift on your keyboard. And if you look at all the buttons, there's little words in blue. The second allows you to use those blue words. So instead of typing sine, if I hit the sine button, it'll do sine inverse. So let me go ahead and do... What we actually have to do is tangent inverse. So second, I'm going to hit tangent for tangent inverse. She has a little -1. And then 14 over 13. Close the parentheses. You don't have to when it's just this, but it's just a good habit to do is close your parentheses because the calculator will mess up. And when you do that, it tells you the angle. So the tangent inverse got this ratio. And it goes, okay, if I was part of a triangle... What would my opposite side and my adjacent side be? It's 14 over 13. What angle creates those opposite sides? 47.12 degrees. Go back here, 47.12 degrees. All of the inverse functions work this way. We could have done it with cosine. Screw it. We'll do it with cosine of B. How about that? Catch me outside. Please? Ah! this time, we're going to find the measure of angle B, and we're going to use cosine. So, cosine of angle B. Let me scroll back up for a little bit to look at my SOHCAHTOA. Again, I don't want to keep scrolling all the way to the top to see the full equation. I'd rather you get used to SOHCAHTOA being your way of referencing it. You can write it so quickly. The letters all stand for the same thing. Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse. Great. So I go back here. I know cosine is adjacent to hypotenuse. So here's B. I am now focused on B. I need to find the adjacent side and divide it by the hypotenuse. Well, I already know the adjacent side. I did it with tangent. Tangent said the adjacent was, let me look over here, TOA. Adjacent's on the bottom. So 13. Great. Tangent also used opposite. Oh, wait. No, I made a mistake. That's the adjacent to A. See? You'll make mistakes all the time. I need to look at the adjacent to B. The adjacent side to B. Back in the corner, you have two walls touching you. You got one that is the biggest side of your triangle. That must be your hypotenuse. So that goes on the bottom. And you got the other one that's touching your side. That must be the adjacent. We have 14 over 15. Great. But again, we don't care about the cosine of B. We care about B. So we need to get it out of the cosine function by using its inverse. Cosine inverse of the cosine of B is equal to, oh God, cosine inverse of 14 over 15. There are tears streaming out of my eyes, and I can feel myself getting more stuffed up. I'm going to try to get to law of sines and law of cosines after this. No promises. Oh my God. All right. Cosine, just like how tangent inverse and tangent of A canceled each other out to get A, cosine inverse cancels out cosine to just get B. Over here, I have cosine inverse of 14 over 15. Just like before, pop this guy open. Second, to get the shifts for the cosine inverse, and it was 14 over 15. Close the parentheses, enter. So now, this knows that angle is 21.0. I'm going to round up to 4. So 21.04 degrees. We could do it again with sine, but we don't really have to, and I'm falling apart. So I want to try to at least do a little bit of law of sines and law of cosines. Yeah, that's the plan. Ugh. Okay. I don't see any questions in the live chat if anyone has any questions, but feel free to ask them if you had any. We are going to move on to law of sines and law of cosines. I'll move this way. Oh my God. I should save this. All right. Please stop. Law of sines. Something I said at the very beginning. Not everyone was here. We can only use sine, cosine, and tangent how we've been using it with right triangles. What happens if we don't have a right triangle? We have a triangle that has a bunch of different side lengths. See, that's much easier for me to draw. So let's say A, B, C, lowercase b, lowercase c, lowercase a. Great. All of these angles are different lengths, or different angles, measurements. They don't always have to be different, but none of them are 90. What happens here is that we can still use trig to solve for missing aspects of the triangle, but we got to manipulate the trig functions in a weird way. I'm going to write the law first. I'll say it out loud as I'm writing it, but then I'll explain it afterwards. So the law of sines is the sine of capital A over A is equal to the sine of capital B over B, and it's equal to the sine of capital C over C. Oh, God. I can hear that I sound awful, so I apologize. So what this means is that, again, how trig functions work is that they take in an angle, and it's almost like you can imagine it's a person thinking about that angle and going, okay, if that angle was in a right triangle, what two sides would be the opposite and hypotenuse for sine? And for cosine, it's going, what would be the adjacent side and what would be the hypotenuse that make this angle work? So essentially what this is saying is if you got the sine of A, so the trig function is going, what ratio created this angle? And it gives you that ratio. Whatever that ratio is, if you divide it by the opposite side, it will be the same exact answer as if you did it for B and if you did it for C. So sine of A, capital A over A, sine of capital B over B, and sine of capital C over C. You want to use this. Use for non-right triangles. I am so bad at this. And use... Oh, God. I should be off of Steam so you guys don't see those names. I'm so sorry. I didn't even think of that. Okay, there we go. Ignore that. You want to use when you have at least two angles and one side, or two sides and one angle. I know that's a lot. My bad. Essentially, you can't use this if you have if you don't have all the information. What I mean by all the information is you need to at least set up two fractions. Two of these fractions, set them equal to each other so you can start solving for things. If you don't have a fraction that has all of its pieces, you can't solve for anything because then you're working with two variables, and you don't do that until later in calculus and algebra 2 and stuff. So let's go ahead and do an example. I will make up numbers. I'll just use this as a reference. So I will say that we are going to have two angles, and we're going to solve for a side first. So we'll say this is, 42 degrees, I guess. We're going to solve for that side, and we'll say this is 28 degrees, and this side is 6. Great. So first thing, there's two things you can do. You can set up a fraction that has both the angle and the side, or you can set up a fraction that has your variable. I'll do the variable first. So sine of something divided by something is equal to sine of something divided by something. If you want to set your law of sines up this way every time, that might be helpful. You have your blanks and you just fill in. So I want to have one of my fractions have x in it. X is a side. It's the lowercase a. So if I look at my equation, the lowercase letters go on the bottom. So I'll say it's on the bottom here. Well, if you look at your equation, the letter corresponds to its opposite angle. So if x is on the bottom, its opposite side is 42 degrees. So that must go into here. What goes into your trig functions when they're not inverses is always an angle. It'll never be a fraction that goes in here unless it's an inverse. If it's just sine, cosine, and tangent, standard, it is just an angle. It'll never be anything else. So keep that in mind when you're placing your letters in. The side lengths go on the bottom. The angles always go inside the trig function. Anyway, so that's one fraction. Sine of an angle divided by its opposite side. Side of an angle divided by its opposite side. I'll do it again. I don't have anything for B or this B, so I'm not going to worry about it. But I do have this angle, C, and I do have this side, 6. Well, I'll do it this way again. 6 is the side, and 28 is my angle. Lovely. We have them set up. Now it's algebra time. So I'll do a quick example of how cross multiplication works right over here. So cross multiplication. Is that spelled right? Sure. Anyway, let's say we have ourselves this fraction, 10 over x, and we have it equal to 17 over 4. I need to figure out what x is. So what we did before, we did an example where we wanted to cancel something out of the denominator. We multiply by that denominator. X divided by x is 1. 1 times 10 is 10. So that's all that's left. If I multiply one side by x, the other side must multiply by x. And I can do that at the same time as I'm canceling out this 4. I want to get everything out of the denominators. I don't want anything in the denominators anymore. I don't like dividing by things. No one really does. So let's get them out. If I had multiplied this side by x and those canceled, I would multiply this side by 4. And those will cancel. If I multiply this side, I must multiply this side. X is cancel. 4 is cancel. What is left is 4 times 10 is equal to 17 times x. In other words, 40 equals 17x. And the last step, when you are multiplying something to a variable, you must divide by that thing to get rid of it. 17 divided by 17 is 1. 1 times x is x. And then we divide 40 by 17. That does not divide cleanly, so bust out your calculator. 40 divided by 17 is equal to 2.35. I'll leave it at that. 2.35. I know this seemed like a weird side tangent, but also that wasn't a pun. But that's exactly what we're going to do here. This whole thing, how I'm multiplying by both sides, the same thing, or I'm multiplying this side by 4 and by x, and this side by x and by 4. This is called cross multiplication. Essentially, what you can do is just put arrows to help yourself go, the x is going to go up here, and the 4 is going to go up here. And you can skip all this canceling out stuff. So I'm going to do that over here. Right over here, I'll go ahead and show you how cross multiplication can be drawn. This x is going to just move up to that side, and this 6 is going to move over here. These arrows are just doing the work of canceling stuff out like we did here. So instead of having to do all the different steps, I am just going to draw the arrows to show how cross multiplication works. So I get 6 sine of 42 is equal to x sine of 28. This is where it looks scarier than it is. It is still the same exact process of what we just did. What we just did is when we moved the things over, we divided by 17. Why? 17 was touching x. They're multiplying together. You want to do the opposite of what's the operation that's happening. So since 17 is being multiplied, we divided both sides by 17 to get rid of it. Over here, what's multiplying to x this time? The entire sine of 28. Sine of 28 is just a number we haven't punched into a calculator yet. We're not punching it into the n because we don't want to round. Divide both sides by the entirety of sine of 28. Earlier I said you can't divide by a trig function. True, you can't divide by a trig function by itself. But if you have the trig function with information on the inside, you can, because that's just a number. So right here is this big ugly fraction that we'll deal with in a second. But over here, just like how the 17s cancel out, the sine of 28 will cancel out. That goes away, that goes away. All that's left is x on this side. Over here is where it gets a little funky. This can be hard to type into a calculator. I strongly encourage that you get used to typing these in, especially working with your parentheses. Put in extra parentheses if you need to make it easier for yourself. Your denominator should always be in parentheses so your calculator doesn't get confused. And in this case, I would also put the numerator in parentheses when you're typing it in. I'll do it right now. So 6 sine 42. So on the top, I'll put 6 times the sine of 42. Close the sine parentheses and then close the numerator parentheses. So now the calculator knows that this is all one thing that's going to be on top. Divided by. And on the bottom was sine of 28. I don't need to put this one in parentheses, but I'm going to anyway. It's still good practice. Sine of 28. Closing both the 28 and the denominator. I hit enter. 8.55. So in this case, x is 8.55 or 8.6, however you round it. That was for solving for a missing side. We're going to do one where we solve for a missing angle. Give me 1 second. All right. Let's solve for a missing angle, and then we will do law of cosines and call it a day. I need to take Benadryl so I don't swell up into a balloon. All right. New triangle. We're going to do x. Oh, my God. What is wrong with me? New triangle. This is x, y, and z. We're solving for an angle this time. So we'll get one angle. I'll say this is 64 degrees. We're going to solve for z there. I'll put x degrees. I'll put z degrees. Whatever. We'll use z as the variable. Z degrees. We'll say this side length is 12. And we'll say this side length is 7. Once again, let's go ahead and scroll back up to the law of sines, how it looks. Sine of an angle divided by its opposite side is equal to sine of a different angle divided by its opposite side, and so on. So, I need to do that. Oh my God, I have horrible handwriting. I just scrolled down to this. Are you kidding me? You guys respect me? That's crazy. So, I need to make my two fractions. I want to make the one this time that has all of the information. So, I need something that has the side and the angle in it. Sine of 64 divided by 12. 64 is the angle. Its opposite side is 12. It's equal to sine of z, our angle, and that's going to be divided by its opposite side, 7. Now, this time we don't have to cross multiply. Our exponent, or not exponent, what is wrong? Variable. Our variable is on the numerator. So we only just need to get rid of the stuff surrounding it. You got to pretend like this is just an x that we're solving for. We got to get rid of everything happening to it. So if we have a denominator, we must multiply by that denominator. If we multiply one side, it multiplies to both. This side cancels. I get 7 times the sine of 64 over 12 is equal to the sine of z. This is where a lot of you will get stuck. A lot of you will get confused. Be like, am I done? Do I just type this in and I'm done? Well, no. We need to figure out what z is. And that brings us back to inverses. Remember? I'm going to scroll randomly to see if I find it. It's right here. Totally. Oh! That was real excitement. I'm sorry. You want to use sine inverses to cancel out standard trig functions. Right here. Sine inverse cancels out sine. It's exactly what we got to do here. Sine inverse of this whole fraction. 7 sine of 64 over 12 is equal to the sine inverse of the sine of z. These cancel. That's the rule of inverses. And we get z. Here is also where you're going to get tripped up when you're typing stuff in. Parentheses really, really matter. You got to have numerator parentheses so it knows what you're multiplying. It knows what you're going to be on top. You got to have the ones that surround the whole inverse. You got to have the ones that are inside this sign. I will demonstrate. So we got Let's see. Nope. Okay. Second, sine inverse. Okay, numerator is 7 times the sine of 64. If you notice, all of your open parentheses, you can count them. 1, 2, 3. So I must have, to finish this up, to close it all up, I must have 3 closing ones. But I have 1 that signifies the top of my numerator. I have 1 that signifies my sine. This one closes the sine. This one closes the numerator. Divided by 12. And I'm going to close the whole thing. So I have 1, 2, 3 open ones and 1, 2, 3 closed ones. Done. So I get that the missing angle is 31.62. 31.62 degrees. Giving my hand a break for a second. I'm going to have this video saved in case you guys want to watch it later for more help. I'm just stretching my hand. Okay. Let me go ahead and find another spot, and we'll do law of cosines. We're going to do one example. Oh, God, I'm sorry. We're going to do one example of law of cosines because I can't. All right. Law of cosines. Now, that's an S, I promise. Law of cosines, it can be used in the same way law of sines is, but in one other way. Use when you have no. That's an N. Oh, what is wrong with me? No angles. So the best thing you can do is when you run into a problem and it's like use law of sines or law of cosines, try law of sines first. See if you can set up your equation, and if you can't, then you know you got to use law of cosines. Now, either one can be easy or hard depending on what kind of math you prefer. Law of sines uses more algebra. Law of cosines is plugging stuff in. But you got to be better at your order of operations. And it's going to look really gross, and I'll explain it here in a second. So let me write it out first, just like last time. C squared is equal to A squared plus B squared minus 2AB cosine of capital C. Now, I know this looks awful, but if I was to just cover up, like I'm going to scribble over it. If I did this, what's left over is something that we already know. What's left over is, I want to do another random scroll. I was almost there. Not even close, never mind. Way up here, Pythagorean theorem. The basic stuff with right triangles. You can only use Pythagorean theorem with right triangles. A squared plus B squared equals C squared. If I go back down to my new law of cosines, what I just covered up leaves me with A squared plus B squared equals C squared. Essentially, law of cosines allows us to use the Pythagorean theorem on triangles that aren't right triangles. So another one of these. Let's see, G, H, and K. We don't have any right angles. All of these angles are going to be different because I said so. And, oh, no, I shouldn't do G, H, and K. It's going to confuse everybody. Never mind. Hang on. Hang on. Shut up. Calm down. You calm down. It was a misinput. A, B, and C, lowercase, lowercase, lowercase. Okay. I know this looks long and bad, but honestly, what you need to focus on are two aspects. The letter that's inside your cosine equation and the letter that's out here on the left side. Those need to be opposite sides of the triangle. They need to be corresponding and opposites. The other two, A, B, and A, B there, are just whatever left over. Those can go in any order. It doesn't matter. These are the only ones you focus on. If you're looking for an angle, if the question requires you to find an angle, that angle will be here, and its opposite side will go out here. If the question is asking you to look for a side, that side will go out here that you're looking for, and its opposite angle will go in here. There is everything else just needs to slot in. That's the only thing you need to focus on. The lettering here will change depending on what letters you're working with. I left it back to ABC because if I did GHK, that would have screwed everything up. But that's what you'll run into. You'll run into GHK. You'll run into XYZ, PRQ. It doesn't matter. What matters is the positioning. The opposite side and its opposite angle must be corresponding here, and the other side slot in. Let's do one and only example so I can go blow my nose for 15 hours. Okay. We'll say that this is 12. We'll say that this is, 17. And this is 16. Whatever. And we're going to solve for a missing angle. B. We're going to solve for B. So I'll put an X there. We're going to solve for B. So let's go ahead and set it up how I said you should. Always put your equal sign. And then I'm going to go move over here, give me plenty of space to do the cosine of my angle. Oh, it's always a good practice to, until you get used to it, because I don't write it like this, but until you get used to setting up your equations without thinking, always place your variable first and then fill in the rest later. So again, focus on the thing that goes in your angle and its opposite side. X is going to my angle. There's my X. So I go to its opposite side. And that goes out here. The other sides just slot in where they need to go. 12 squared plus 16 squared minus 2 times 12 times 16. Here, again, a lot of you, understandably, will get overwhelmed. There's just numbers on screen. If you have dyslexia, this is a nightmare. I apologize if you have dyslexia. This can be a lot. All you got to do now, though, is your order of operation. Parentheses, exponents, multiplication, division, addition, subtraction. And we're trying to solve and get x by itself. We got to get x alone. Really quickly, if you have a missing variable inside of a trig function, just know ahead of time, you are going to have to use an inverse. It's always going to happen at the end, but leave it for the end. So first of all, let's go ahead and do all of these squares. I don't know most of those off the top of my head. 17 squared. 16 squared. So 289, 256. Okay. So 289 equals 144 plus 286 minus what is 24 times 16? Who knows? 24 times 16. 384. Cosine of x. Lovely. Once again, a lot of you will see these numbers here, these big numbers. One, panic, and two, want to get them into one number. You'll see 144, 286, and 384 and be like, oh, those can combine. However, they cannot. This right here is connected. They are being multiplied. You cannot add and subtract things that are being multiplied. These are stuck together. They cannot be removed until we divide later on. So let's go ahead and combine what we can to combine. 289 equals 144 plus 286. What's that? 290 plus 40, is that 330, 430? Right? Yeah? Am I dumb? I don't trust myself. 144, 286. 144 plus 286. Let's go! Okay. Minus 384 cosine of x. Again, can't do it. You cannot combine these two numbers. The 384 and the cosine of x are attached. So I'm going to go ahead and move this down a little bit. I need to get rid of this number. It's a positive, so I must subtract it. Minus 430, minus 430. Again, I don't want to do basic math in my head. 289 minus 430 equals negative 141. Negative 141 equals negative 384 cosine of x. Right now we have a number that's multiplying to essentially a variable, so we must divide by that number to get rid of it. Right here we have two negatives. When you rewrite it, you could just make it a positive. Two negatives being divided or multiplied together become positive. So if you don't like negatives, just get rid of them. So I'm left here. I have one step left. I need to get the x out of the cosine function. I need to get it alone. So I must inverse both sides. 141 over 384 is equal to cosine inverse of cosine of x. These cancel. This is left with x. I now just type this in. Cosine inverse 141, 384. Cosine inverse of 141 divided by 384. 68.46. 68.46 degrees. That is the harder version, honestly. The type I didn't do was we're solving for an angle. When you're solving, when you're solving for a side. When you're solving for a side, all you do is plug all this into a calculator and you get to your answer. You'll have to square root at the end to get rid of the square, but that's essentially it. The harder one is definitely the inverse. So I wanted to do that one. I don't see questions. I only see like 4 people in here. Do we have any questions? Anything you want me to go over again before I take 6 Benadryl? I'll pause for a second here because I know there's like a 20-second delay. There's a lot of stuff. Maybe I'll save this and post it somewhere. I don't know. All right. I don't see any questions. I am going to go die. Not really. I'm joking. How do we get the hypotenuse? Again, the hypotenuse is... Where'd it go? Oh, scroll up. Scroll. Hypotenuse. You don't really need to find the hypotenuse. It is kind of given to you. The hypotenuse is always the biggest side, the longest side of the right triangle, and it is always opposite the 90 degrees. So if you see a 90-degree angle, you know that the opposite side, if you've pretended this is the back corner of the room, you walked across the room and hit your face on the wall, that wall is your hypotenuse. So whenever you need to find one, if you need to get one, that's how you find it. Or if you have the two sides, A and B, you can plug it into Pythagorean theorem and get it that way. Quick example of that. Let's see. Nope. There we go. That's a right triangle. See? Told you. Let's say 3, 4, and x. Okay? We're going to do a quick Pythagorean theorem in case you need to find what the hypotenuse is. C in the Pythagorean theorem is always the hypotenuse, as signified here. So I'll set up the equation. 3 squared plus 4 squared is equal to x squared. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. And that equals x squared. 9 plus 16 is 25. To get rid of a square, you must square root. Those cancel. The square root of 25 is 5. So if you're just working with the right triangle, Pythagorean theorem will get you your hypotenuse. But if you're just trying to identify which side is the hypotenuse, it's the opposite to 90 degrees, and it's the biggest side. Great question. I'll pause again if there's any more, and then I for sure am getting off. All right. Thank you for those that were here. Hopefully it went well. I'm gonna try to do one again tomorrow and potentially Wednesday, but not Thursday or Friday. Uh, I have work obligations Thursday and personal obligations Friday. So hopefully I can do one tomorrow and Wednesday for more questions and more practice. We're gonna do some stuff with circles tomorrow, and then we'll do like volume and stuff like that on Wednesday. Thank you for watching. I am gonna go blow my nose.